Welcome you all to the problem solving session of week 7 of the differential equation for engineers. Myself Guru Bachchan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of practical geometry and dynamical systems. In this week problem solving session, we mainly focus on the Sturm-Liouville problems. So you can say particularly the regular Sturm-Liouville, periodic Sturm-Liouville or singular Sturm-Liouville system. So let me start with the first question. Question number one, find the eigen values and eigenfunctions of the Sturm-Liouville system. And what is Sturm-Liouville system here given? Y double dash plus lambda y equal to 0, y 0 is 0 and y dash at 1 is 0. So this is your given regular Sturm-Liouville. Why I'm saying regular? So let me first mention that. So what is the general form of regular Sturm-Liouville system? So regular Sturm-Liouville system. So regular is defined in the following way that Ly equal to some lambda y, where L is minus 1 by this weight function and d over dx of px d by dx plus qx. Okay, and furthermore conditions are that px should be greater than 0, there is no condition on qx, and weight function should be positive, and this is for all x in AB. So x belongs to AB. And what are the boundary conditions? Boundary conditions are alpha 1 y1 a plus alpha 2 y1 dash a is 0, beta 1 y1 a will b, and beta 2 y2 dash of b is 0. And this both alpha i's are not 0 at the same time. Also, both beta i's are not 0 at same time. Okay, so both alpha i's cannot be 0 at simultaneously. So at same time you can say simultaneously, both 0 simultaneously. And for this also you can say the same thing, that this cannot be also 0 simultaneously. Okay, so this is your regular Sturm-Liouville system. So here what is your px if you will write in this ly plus lambda y form. So we have given y double dash plus lambda y equal to 0. So what you can do, we can write it as ly equal to lambda y, where l is minus 1 by 1, because it will be minus y double dash d by dx of 1 into d by dx, plus qx should be there. So here there is no qx, so it will be 0. So what you get? You get qx is 0, weight function is 1, which is greater than 0, px is again 1, which is also greater than 0 for all x in AB. And corresponding to this, what is the inner product? Let me write here. F comma g inner product is a to b with weight function fx. Let me write in some form t, omega t, ft, gt conjugate dt. So this is your inner product mainly. Okay. So here what will be the inner product? Inner product will be f g, since weight function is 1, so it will be, and the ODE defined from 0 to 1, since we have given the boundary condition y0 and y1. So 0 and 1, f t g t complex conjugate. And you can observe that we have also given that y0 is 0 and y dash 1 is 0. So these both tell you that not both alphas and not both beta j's are 0 at the same time, or you can say simultaneously. So you identify that the given ODE is nothing but it is a regular Sturm-Liouville system. So now this was original given ODE. What you will look? You will look for the solution yx of the form e to the power kx. And if you will look in this form, what will happen? It will be k square e to the power kx plus lambda e to the power kx is 0, and from here k square plus lambda e to the power kx is 0. Since e to the power kx cannot be 0, so it will imply k square plus lambda is 0, because e to the power kx is non-zero for all x in, you can say, in fact in general, but here since it's a 0 1, so it's a 0 1. So now you have to divide the case, because lambda belongs to R. So there will be three cases: lambda greater than 0, lambda equal to 0, and lambda less than 0. These three cases you have to deal with. So what you will do? So you will start with the easiest case, that is lambda equal to 0. So try yourself. First of all, lambda equal to 0, then greater than 0, then less than 0. What we have to do, we have to find out the eigenvalues and eigenfunctions, and we know that eigenfunctions are non-zero vectors. So we have to find out such eigenvalues with respect to which the solution is a non-trivial solution. So try this one. So let us start with the case lambda equal to 0. So when lambda equal to 0, then this equation 1 will correspond to, let me choose some different colors so it might be visible then. So let me choose this one. So lambda equal to 0, this is the first case. So what will happen in case of lambda equal to 0? So this equation 1 will imply k square will be 0. That means both the roots are 0, 0. So what will be your yx? Your yx will be c1 e to the power 0x, since it's a repeated root. So c1 e to the power 0x plus c2 x times e to the power 0x. So this will give you c1 plus c2x. Yx is equal to this. Now we have to apply the boundary condition. So we have given y0 is 0. So this will imply c1 plus c2 into 0 is 0. So this will give you c1 equal to 0. Y dash 1 is 0. So what is y dash x? Y dash x is nothing but c2. So this will imply that y dash 1 will be c2, and from this condition you will get that c2 will be nothing but 0. So that means yx is 0 on whole domain. So which will imply, therefore, lambda equal to 0 is not an eigen value for this Sturm-Liouville system. Okay, what will be the next case? Since we have considered lambda equal to 0, the next case will be lambda greater than 0. Or let us consider the easy one, lambda less than 0. You will get to know why it is easy. So what you will do, since lambda is less than 0, you will consider minus mu square. Since mu square is always positive, so lambda must be negative quantity. You can judge that. And also we are taking mu to be positive. The reason is that if you will take mu to be negative also, then both the solution give the corresponding to mu greater than 0 and corresponding to mu less than 0, both the solutions will be give you the same family of functions. For example, if I would say, for example, yx is equal to a cos mu x plus b sin mu x, while if you will put this is correspond to mu, this is correspond to minus mu, so this will give you a cos mu x, and this will give you minus b sin mu x. If you will observe that, you can just change the arbitrary constant and the solution will be the same. So what we will do, we will only consider mu to be positive. So therefore, me erase this one. So therefore, here we will work with this minus mu square. So your equation will imply that k square minus mu square will be 0, then that will imply k must be mu comma minus mu. Okay, so if k equal to mu comma minus mu, then yx will be e to the power mu x c1 times plus c2 times e to the power minus mu x. Since we need again we're going to need that its derivative, so what we will do, we will will do the derivative of it. By chain rule, it will be c1 mu e to the power mu x minus c2 mu e to the power minus mu x. So we have given that y0 is 0. So this will give you c1 plus c2 is 0. So suppose this is your equation number 2. Y dash 1 is 0. So this will give you C1 mu e to the power mu minus C2 mu e to the power minus mu is 0. What you can do? Or you can either solve for C1, C2, and otherwise you can see the determinant. So we are saying that if second and third, if we want that it has a system, the system second and third has a non-trivial solution, then we want this. If the system this, then what should be happen? The determinant must be 0. Okay. So what is the determinant here? 1, 1, and here will be mu times e to the power mu minus mu times e to the power minus mu. Or let me write it more appropriately in the way that so let me write first of all what is this system. System is 1, 1 mu e to the power mu minus mu e to the power minus mu multiplication with C1, C2, 0, 0. So this is your equation number star. So I am saying that if the system star has unique solution, then this Wronskian must be 0, or you can say determinant of the matrix this A must be 0. So what is its determinant? So its determinant will be minus e to the power minus mu minus mu e to the power mu. We are saying that this should be 0. That means mu e to the power mu e to the power minus mu is 0. But for any mu greater than 0, you can say for all mu, which is a contradiction. Since it is not positive, this cannot be positive, then what's going to be happen that we have assumed the wrong assumption. So that means it must have the system must have a trivial solution. Therefore, C1, C2 will be nothing but 0, 0. Again, then we say that lambda less than 0 does not have any eigenvalue, or you can say does not contribute in the sense of eigenvalue for the given SL system, that is Sturm-Liouville system. Next case left we will with lambda less than or greater than 0. So the last case is lambda greater than 0. So again, what will you assume? Lambda is some mu square type and mu is positive. So your equation 1 will imply that k square plus mu square is 0. Then k is equal to plus minus iota mu. So this will give you the general solution in the form C1 e to the power iota mu x, or you may write cos mu x plus C2 sin mu x. So I think this I hope, let me just change this color. Okay, so since this is C1 cos mu x and C2 sin mu x, So what will be its derivative? Its derivative will be minus C1 mu sine mu x plus C2 mu cos mu x. We have given y0 is 0. So this will imply that C1 is 0. Okay. Next we have given that y dash 1 is it 1 or is it pi? Let me check it. Y dash 1. Okay. So this one will be y dash 1 is 0. That means since C1 is 0, so we will left with C2 mu cos mu is 0. Since we want non-trivial solution, so what will we assume? Because we want non-trivial solution, therefore let C2 to be non-zero. And we know that mu is greater than 0. Therefore, the left thing will be cos mu is 0. Cos mu is 0 only when is of the form 2n minus 1 pi by 2, where n is any natural number. Okay, so you got some mu corresponding to which you get a non-trivial solution. Non-trivial solution means non-zero eigenfunction. And what will be the corresponding eigenfunction? The corresponding eigenfunction will be, since C2 is arbitrary, you are saying C2 is non-zero, so iska matlab, or that means C2 is arbitrary. Hence, the eigenvalues for the given SL system are, since lambda is equal to mu square is the eigenvalue, therefore it will be 2n minus 1 square pi square divided by 4, where n is natural number, and the corresponding eigenfunctions are the function that is with respect to C2, that is sine mu x. So corresponding eigenfunction will be sine mu x, that means 2n minus 1 pi by 2 into x, where n is any natural number. So this will be your final answer for this corresponding system, Sturm-Liouville system. Okay, so let me verify it. So this is the 2n minus 1 square pi square. Yeah, so it's correct. So let us move to the next question. In this question, what we will do, we will discuss another Sturm-Liouville system, which is somewhat different with this regular system. So second question is, find the eigen values and eigen functions of the periodic. Here we are mentioning by ourselves periodic SL system. So what is the system? Y double dash plus lambda y is 0, where this x varies from for x 0 to pi. Now the natural question arises, we have not given here by the boundary point condition. So what we are going to do? So let me recall that what is the general periodic SL system. Then you will try by yourself. So general periodic SL system is like this. So Ly equal to lambda y, where L is nothing but minus 1 by Wx d by dx of Ex d by dx plus some Qx. Okay. So this is your general system. Not this is not exact system. So now you have to put some boundary condition with boundary conditions. Since we want to make this L to be Hermitian, so the boundary condition will be y a equal to y dash a and y b equal to y dash b. So this is your periodic SL system with the inner product Fg, which is defined as A to B Wx Fx Gx conjugate dx. So this is your general given periodic SL system. So from here you obviously got to know that. So there is some typo. So typo is YA should be YB and Y dash A should be Y dash B. So this is your periodic system, periodic SL system. So your given system will transform to Y double dash minus 1 is equal to lambda Y and Y0 is Y pi and Y dash 0 is Y dash of pi. So from here you will get to know that Wx will be 1 again, Px will be again 1 and Qx will be 0. And since you have given this boundary point condition, so what you will do, you will divide the case y double dash plus lambda y equal to 0. So what you will do, look for yx to be the type of e to the power kx. So this will give you k square plus lambda equal to 0 again. So for this is the equation number 1 for this particular question. Again, you will divide the cases for lambda greater than 0, less than 0, and equal to 0. And then we'll try to get apply this boundary point condition and try to get some eigenfunction that is a non-trivial solution for the given SL system, similar to the question number 1. Try this one. So let us divide the cases again. We will start with the easy one. First of all, lambda equal to 0. So lambda equal to 0. What it will give you? It will give you k square equal to 0. That means what are the roots? 0 and 0 repeated roots. Then yx will be have the form c1 plus c2x. Since we have given y0 equal to y pi, this is so y0 is y pi. So this will give you c1 equal to c1 plus c2 pi. So from here you will get c2 to be 0 and c1 is arbitrary. The next one is y dash 0 is equal to y dash pi. Then this will give you the derivative of y dash x will be what? Its derivative will be nothing but c2. So it will give you c2 equal to c2, that is nothing but 0 equal to 0. That means c1 is, it imply c1 is arbitrary. If c1 is arbitrary, that means you have a non-trivial solution, that is x. So therefore c1 is arbitrary, that means you have non-solution 1. So therefore y x equal to 1 is an eigenfunction corresponding to the eigenvalue lambda equal to 0. So lambda equal to 0 is contributing here as an eigenvalue, and the corresponding eigenfunction is yx equal to 1. Next case is lambda is less than 0. So let us do lambda is less than 0. So again, you will consider lambda to be minus mu square, where mu is nothing but a positive quantity. So from here you will get k square, 1 imply will k square minus mu square equal to 0, which will give you k equal to plus minus mu. Again, the general solution will be yx equal to c1 e to the power mu x plus c2 e to the power minus mu x. Since you need the derivative, you will differentiate from here c1 mu e to the power mu x minus c2 mu. Since it's a minus mu, so minus c2 mu e to the power minus mu x. Okay. So from here y0 was y pi. So this will give you c1 plus c2 equal to c1 e to the power mu pi plus c2 e to the power minus mu pi. So from here you will get c1 as 1 minus e to the power mu pi and plus c2 equal to 1 minus e to the power minus mu pi is 0. So this is your equation number 2. Next is y dash 0 is equal to y dash pi. So this will be c1 mu minus c2 mu equal to c1 mu e to the power mu pi minus c2 mu e to the power minus mu pi. So this will give you c1. We can since mu is positive, because mu is positive, so we can cancel it out and we can ignore it. So you will get 1 minus e to the power mu pi with negative sign c2 uh, 1 minus e to the power minus mu pi equal to 0. So this is your equation number 3. Again, you can directly add them. So second plus third will give you 2 times of c1 e to the power 1 minus e to the power mu pi, which is 0, and this can be 1, this can be 0 only if mu is 0, non-zero because mu is positive. So this will imply that c1 is 0 again. So this will imply c2 into 1 minus e to the power minus mu pi is 0. So this is a non-zero quantity because mu is positive. Therefore, c2 is also 0. So y-axis trivial solution on whole interval. Therefore, lambda less than 0 is not an eigenvalue, sorry, not an eigenvalue of the given SL system. Okay. Now we are left with the only one case, that is lambda greater than 0. So let us do that one also. Lambda greater than 0. So what will happen in the case of lambda greater than 0? You will assume lambda to be mu square, where mu is a positive quantity, and equation 1 imply that k square plus mu square equal to 0, and k will be plus minus iota mu. So from here you will get the solution c1 cos mu x plus c2 sin mu x. Okay, so let me just verify this one also. So from here we want the solution to be non-trivial. So since we want the solution to be non-trivial, so why again we calculate its derivative. It will be negative sign c1 mu sin mu x plus c2 mu cos mu x. So y0 is y pi. So this will give us c1, and since sin 0 is 0 is equal to c1 cos mu pi plus c2 sin mu pi. Since we are not aware about mu is an integer or you can say non-integer, so we cannot keep it, we cannot put it equal to 0. Thus, from here you will get c1 1 minus cos mu pi minus c2 sin mu pi equal to 0. This is your equation number 4th. Since we have taken 1, 2, 3, we have numbered 1, 2, 3. So this will be our 4th. Next is y dash 0, y dash pi. So y dash 0 will here. So this factor will be 0. You left with c2 equal to c1 with negative sign. Since here is a mu and mu is a greater than 0, so I'm obviously we can take it common and cut it. So I'm skipping that step. I'm directly writing c1 sin mu pi plus c2 cos mu pi. Okay, so this will give you c1 sin mu pi plus c2 into 1 minus cos mu pi. So this will be 0. So this is your equation number 5. Combining this, you will get a system, and system is like this: 1 minus cos mu pi sin mu pi minus sin mu pi 1 minus cos mu pi C1, C2, 0, 0. Okay, so this is your system because, yeah, or you can say let C1, C2 is some non-trivial solution. Therefore, this determinant must be 0. That is 1 minus cos mu pi sin mu pi minus sin mu pi and 1 minus cos mu pi. This determinant must be 0 and the value of this determinant will be 1 minus cos mu pi whole square plus sin square mu pi is 0. So this will give you 1 plus cos square mu pi plus sin square mu pi is again 1 minus 2 times of cos mu pi is 0. So from here you will get cos mu pi is nothing but exactly equal to 1. Now we have to find, we have to think for which value of mu pi or which value of the angle the cos angle will give you the positive value. Since we cos is 1 with respect to the even integer cos 0, cos 2 pi. So what we will write here 2n pi, and where n is from natural number since we are talking about only positive. So mu will be nothing but 2n where n is, and again since C1 C2 both are non-zero, so both the vector, both the functions will correspond as eigenfunction. So let me write it. So hence the eigenvalues of the given SL system are 0 and 2n where n is natural number, and the corresponding eigenfunctions are, in the first one the corresponding function was 1, and in the second one the corresponding function is cos mu x, that is 2nx, comma sin 2nx where n is natural number. Okay, so this is your corresponding eigenvalue and eigenfunction for this system. So what we can do, we can just put the color here so that you can find out which is the corresponding eigenfunction, corresponding eigenvalue. So since it was this is your an eigenvalue and the corresponding eigenfunction is this. This is your corresponding eigenfunction. Okay, and the 0 is the eigenvalue. 0 is an eigenvalue with this, and its corresponding eigenfunction is this. Okay, so I hope till now it's sorry till now it's clear the corresponding eigenvalue and eigenfunction we got here. So this will be this one. Okay, so let me write in the way. This is your corresponding eigenvalue and corresponding eigenfunction. So in the next question, which is some different form, but the approach will be quite similar. Find the eigenvalues and eigen functions of the SL system, and system is given as x y dash derivative plus lambda by x y equal to 0, and boundary condition is given as y1 is 0, y is 0. So we have given this system and we have to find out its eigenvalue and eigenfunction. So if you will see it as lambda y, ly equal to lambda y, so you will get to know that L is minus, since it's a lambda y, so minus this x will goes to LHS minus x divide d by dx of px, that is x into d by dx plus some qx. Here qx is not, what will be qx here? If you will expand this x y dash derivative, so this will give you x y double dash plus y dash. So this will give you, so here no need of to write that because no term of y, so this will be plus 0. So from here you will get to know that your weight function is minus 1 by x, minus 2, not minus, it's positive because in general it's minus 1 by omega x, so it will be positive. And your px is here x, and next is, which is positive on 1 to e. Since we are dealing the boundary 1 and e, so it will be positive in whole domain. Similarly, it's also positive on 1 to e. So now you know that your system is a regular kind of system. So you have divided in the following phase with respect to this qx is 0 for all x from 1 to e. So your inner product will define as 1 to e 1 by x f x gx conjugate dx. Since its weight function is not 1, it's 1 by x. Now in order to see the solution or divide the case, what you will do, you will solve it, this equation, given equation as, if you will solve it, you will get x y double dash plus y dash plus lambda by x into y equal to 0. So this will give you x square y double dash plus xy dash plus lambda y equal to 0, y1 is 0, y e is 0. So this is your given system. If you will observe closely, this is nothing but an Euler-Cauchy form. So what you will do, you will substitute z equal to ln x. So dz by dx will be 1 by x. So from here dy by dx is dy by dz into dz by dx by chain rule. So this will give you dy by dx is, or you can say x dy by dx is dy by dz. Again you will differentiate this, then you will get x d2y by dx square. With respect to x I am saying, plus differentiation of x is 1, dy by dx, and with respect to x, if you will do by chain rule, you will get dz by dx. So this will give you x square d2y by dx square plus x dy by dx d2y by dz square. So this is your conversion of this given differential equation into the Cauchy-Euler equation. So let us check it one more time, or what you can do from here. So I think that this is correct. So, but since we want to convert into the d2y by, we want to find out the value d2y by dx square. So from here, what you can do, x square d2y by dx square will be d2y by dz square, and the value of this is from this you will get minus dy by dz. Okay. Now you put these values into the given equation, x square dy. So this will be d2y by dz square minus dy by. So from before that, what will be the boundary condition? Since we know that x was, we know that x belongs to 1 to e. So if x is 1, so this will imply z will be ln 1, which is nothing but 0. And when x is e, so this will imply z will be ln e, which is 1. So now the domain of z must be 0 to 1. So from here, you will get d2y by dz square minus dy by dz. This is your first term, and the second term will be plus xy dash. Xy dash was dy by dz, and since we are not disturbing y, so it will be lambda y equal to 0. From here, you will get d2y by dz square plus lambda y equal to 0, and y of 0 is, since we have transformed the variable, then y of 0 is 0 and y of 1 is also 0. So this is your recent converted system. So is this looking like the previous system? Yes, it is again looking like the previous system. What you have to do, you have to form it, you have to look for the solution, yz, since here the independent variable is z, of e to the power kz form, and you will solve for this e to the power kz form. So this will be the k square plus lambda equal to 0. Again, you will divide the case k lambda greater than 0, lambda less than 0, and lambda equal to 0. So try this one. So let us divide the cases. Lambda equal to 0. The easiest case to divide. Again, k square equal to 0 from equation 1. So this will imply k is nothing but 0, 0. So again, it's a case of repeated roots. So yx will be look like c1 plus c2x. Since we have given y0 is 0 and y1 is 0, so y0 is 0 will imply that c1 is 0 and y1 0 will imply c2 is 0. So from here, yx is a trivial solution. So if since yx is a trivial solution, sorry. So therefore, lambda equal to 0 is not an eigenvalue for the given SL system. So I'm not again writing that given SL system. I'm directly saying lambda equal to 0 is not an eigenvalue for this particular system that you will assume by yourself. So next is lambda less than 0. So that means k square minus mu square will be 0 and this will give you plus minus mu, and from here you will get the solution c1 e to the power mu x plus c2 e to the power minus mu x. From here, did you need the derivative? No, because in our system y0 is 0 and y1 is 0. So we don't need any derivative, so we will not do the derivative. We will directly put y0 is 0. So y again, I made a little typo here. Typo in the sense that what we have to do, we have considered the independent variable is z. So there will be z, c1 plus c2z. From here, this z will belong to 0 to 1. Ultimately, we have to find out the function in the form of x, but here we are doing in the form of z. So, yz. Similarly, here this will be also z, yz. Okay. So y0 is 0. What will imply? c1 plus c2 is equal to 0, which will imply that c1 is nothing but minus times of c2, or c2 is nothing but minus time of c1. We can say everything, both the things. So for convenience, I'm saying c2 is minus c1. Okay. So next is y1 is 0. So this will imply that c1 e to the power mu. Since c2 is minus c1, so minus c1 e to the power minus mu is 0. So this will imply that c1 e to the power mu minus e to the power minus mu must be 0. Can it be 0? If you will recall that the graph of exponential, this is graph of exponential e to the power mu, and this is a graph of e to the power minus mu. And we have to consider only this region. So positive region, you can say mu and corresponding y. So here this will be, you can say, non-zero because mu is positive. So this will imply that c1 is 0, and if c1 is 0, then c2 must be 0 from this relation. Again, what you will say that yx is exactly 0 for, again, z is exactly 0 for all z from 0 to 1. Okay, so from here you will get therefore lambda less than 0 is not an eigenvalue. Now you have to rely on lambda greater than 0. You need to check the lambda greater than 0. So lambda greater than 0. Again, this will be k square plus mu square equal to 0. K will be plus minus iota mu, and this will correspond yz to be c1 cos mu z plus c2 sin mu z. From here, you are given that y0 is 0. This will imply that c1 is 0, and y1 y1 is 0. This will imply that since c1 is 0, so this factor will not continue. c1 c2 sin mu 0. Let c2 is some non-zero quantity. Therefore, sin mu is 0. If sin mu is 0, that means mu has to be the multiple of pi. 0, pi, 2 pi. So this will be multiple of n pi. And since we want mu to be positive, so this must be a natural number. So n pi is your eigenfunction. Oh, sorry, eigenvalue. And what will be the corresponding eigenfunction? Since therefore C2, or you can say C2 was arbitrary. So what will be your y and x here? Since depending on x, so I am writing y and x. Sine n pi z, where n is natural number and z is from 0 to 1. So again, now hence the eigen values for the given SL system are n pi, where n is some natural number, and the corresponding eigen functions are sine. Again, I'm recalling, since lambda was mu square, this will be n pi whole square, and sine n pi z. What is z? Ln x. So this will be sine n pi ln x, where n is from natural number. So this is your eigenfunction set, and I am, since it's a case of the third part, I'm just changing its color so that it will be easy to identify that from which case it is contributing. In the same way, here in question number 2, let me write it respectively. In question number 2, this will be respectively, since we have two eigenvalues or set of two eigenvalues. And again, it was a 2n, so here will be also this will be 2n square, since we are working on mu square. Okay, and in the first case, or you can say in the first question, we have this one. So this is the your eigenvalue with respect to the third case, and this is your eigen function with respect to the third case. Okay, so this is your question number 1. Question number 2, where we get two eigenvalues, and with respect to those eigenvalues, we got three eigenfunction. One is with respect to first eigenvalue, and another two function with respect to the second eigenvalue. And the last one is, again, we are getting only one eigenfunction, that is with respect to the lambda positive, that is the third eigenvalue case. Okay, so this is the Sturm-Liouville system, and let me give you the another similar kind of question where integrating factor plays a role. So find the eigen values and eigen functions of the SL system. An SL system is given as e to the power 2x y dash whole derivative plus e to the power 2x lambda plus 1 y equal to 0, and the boundary condition is y0 is 0 and y pi is 0. So this is your given SL system. So in this system, what you will do, first you will write in the form of Ly equal to lambda y. So while you writing Ly equal to lambda y, you will get e to the power 2x y dash its derivative um, e to the power minus 2x with this plus y equal to, this is with negative sign, equal to lambda of y. I have divided with e to the power 2x minus e to the power minus 2x. Okay, minus e to the power 2x. So from here, you can say Ly equal to lambda y, where L is the operator, which is minus 1 by e to the power 2x d by dx of e to the power 2x y dash, can say e to the power 2x dy by dx. Okay, plus what is qx here? Since I am taking e to the power 2x common on the whole, so here qx will be e to the power 2x y. So this time your qx is non-zero. So px is e to the power 2x. Weight function is e to the power 2x and qx is e to the power 2x. And with respect to these, what will be your inner product? This will be, since we are defining boundary 0 to pi, and omega x will be e to the power 2x fx gx conjugate dx. So this will be your inner product. So I'm writing this for just for convenience. Next is to find out its solution. So to find out its solution, what you can do, you can derivate it and you can put e to the, since it's about 2x is non-zero everywhere, so you can take the other side of the equation. So let me write it, e to the power 2x y double dash plus 2 times e to the power 2x y dash plus, is it so? It is about 2x y double dash plus e to the power 2x y plus lambda times e to the power 2x y equal to 0. So because e to the power 2x is non-zero for all x between 0 to pi. In fact, it is on whole real number, but we need here 0 to 2 pi, so we are just saying this one. So y double dash plus 2y dash plus y plus lambda y equal to 0. So I'm writing this for the convenience in this way. So from here, you can easily get your solution. You can easily discuss your solution. So if you will combine this one, so it will be lambda plus 1, you can say. Okay, this will be 0. Now again, look for yx to be e to the power kx. So from this you will get k square plus 2k plus lambda plus 1 equal to 0. So from here k will be nothing but minus 2 plus minus 4 minus 4 times of lambda plus 1 divided by 2. So this will give you minus 1 plus minus under root of, from here 4 will cancel out and you will get here minus lambda. So again you will divide the case for lambda greater than 0, lambda equal to 0 and lambda less than 0. So try. So let us start with the first case. So first case will be lambda equal to 0. When lambda equal to 0, this k will give you -1, or you can say -1 two times, repeated 0, 2k square plus 2k plus 1 is 0. So this will give you k equal to -1 repeated roots. So yx will be c1 e to the power -x plus c2x e to the power -x. These two roots will be there. So from here, y0 is 0 and y pi is 0. We will apply this boundary point condition. Y0 is 0 implies c1 plus 0 times c2. So no need to write it. c1 is 0. From here, you get to know that c1 is 0. Next is y pi is 0. So that means since c1 is 0, so c2 pi e to the power minus pi is 0. Since this quantity is non-zero, so this will imply that c2 has to be 0. And from here, you can say that yx is identically 0 for all x from 0 to pi. Next is, so you can say lambda, therefore lambda equal to 0 is not an eigen value of the given SL system. Next case is lambda less than 0. So that means lambda equal to some minus mu square where mu is positive. So from this roots you will get to know that k is equal to -1 plus minus mu. And your solution yx will be c1 e to the power mu minus 1x plus c2 into the power minus mu plus 1x. These two solutions you will get. Oh, sorry, this is the general solution you will get. Y0 is 0. By implementing this, you will get to know that c1 plus c2 is 0. So this will imply that c1 is nothing but, or c2 is nothing but minus times of c1. And we will use this one in the another boundary condition. Y pi is 0. So that means c1 e to the power mu minus 1 pi minus c1 e to the power minus mu plus 1 pi. This is 0. So this will give you that c1 e to the power mu minus 1 pi minus e to the power minus mu plus 1 pi is 0. These two values can be equal only when mu plus 1 or mu minus 1 0, which is not possible. Or you can say this is can never be 0. So this will imply that C1 is 0 and C1 is 0 means C2 is 0 and C2 is 0 means Yx is identically 0 for all x from 0 to pi. Therefore, lambda less than 0 is not an eigenvalue of this SL system. So we left with only the case lambda greater than 0. So for lambda greater than 0, so this k value will be -1 plus minus iota mu. So yx will be e to the power minus x c1 cos mu x plus c2 sin mu x. Okay, so we have given that y0 is 0. So this will imply that c1 is 0 because sin mu x is 0. So y pi is 0. I hope I'm doing the right manner. So This will give you e to the power minus pi. Since c1 is 0, you will be left with the factor c2 sine mu pi is 0. So this quantity is non-zero quantity, and let C2 is non-zero to get the non-trivial solution. Therefore, we are left with the sine mu pi is 0 case. Okay, sine mu pi is 0 means mu pi must be some multiple of n pi, where n is some natural numbers because we want n mu to be positive. So from here, mu is nothing but exactly n for the eigenvalues, and the eigenfunction will be, and because C2 was arbitrary, so the corresponding y and x will be sine mu x, or you can say sine nx. Okay, so if I will conclude this one, so since there was e to the power minus x also there, so if I conclude it, so from here, hence the eigen values of the given SL system are lambda equal to n, where this is mu square, that was, so that means n square, and the eigen vectors, oh sorry, eigen functions, and the corresponding eigen functions are e to the power minus x sine mu x, that is sine nx, where n is a natural number. So let us mention with their respective cases. So this is n square, and this is e to the power minus x sine nx. So this is your eigenvalues and eigenfunctions of the following SL, of the given SL system. So till now we have done the Sturm-Liouville problem in a different manner. Now there is a flavor of connecting this Sturm-Liouville problem with Fourier series, or you can say Fourier transform. Now we will try to focus on that. So first of all, I would like to discuss two questions that will depend on a Fourier series. Then the next one will be depending on, you can say, Legendre Fourier series or Fourier Legendre series. So let me write first one related to the Fourier series, or you can say we can express any function in the form of these eigenfunctions. In what way? So question number 5, expand the function fx is equal to e to the power x in terms of the eigen functions of problem 3. Okay, so in the problem 3, the whatever eigenfunctions we got, we want to express this function in the form of those eigenfunctions. So try this one. So let us recall what is this, how to represent the functions in the form of this Bessel, sorry, Fourier series or eigenfunction. So what are the functions, first of all? What are the eigenfunction? Problem number three. So in problem number three, here is the problem number three. This is your inner product defined, and the eigenfunctions are sin n pi ln x. So we have to deal in this way. So that means we want fx to be written Cn sin n pi ln x in this form. And how this is Cn can be find out? Cn can be find out in the way that you will take the inner product fx with this sin n pi ln x, and this will be the inner product of this series Cn sin n pi ln x with sin n pi ln x. Since we are we are using the index n there, so here we will put it m. So if you will remember from the class that any sine into sine in a product is 0 for different n and m. So this will be exactly same when n equal to m. Otherwise it will be 0. So it will be sine m pi ln x inner product with sine m pi ln x. So from here you will get Cm will be fx sine m pi ln x with the division of sine m pi ln x with sine m pi ln x. So this is your value of Cn and in the form of series. In this way you can represent. And inner product is defined. I'm recalling how the inner product is defined. It was question number 3. So inner product was defined 1 to e. So from here, this is 1 to e, 1 by x, f x gx conjugate dx. Since we are working in the real number, so we can directly say. So now you know how to find out these values. So try this one. Try to calculate the value. So now we can calculate first of all this denominator, value of this denominator. So this will be sine m pi ln x sine m pi ln x. This is the product 1 to e 1 by x sine square m pi ln x dx. So what will you do? You will substitute ln x as some t, and dx by x will be dt. And from here, when x is 1, this will imply t will be 0. When x is e, this will imply t will be 1. Okay, so this will integral will transform from 0 to 1 sine square m pi t dt. So from here you will be 0 to 1, 1 minus cos 2 m pi t divided by 2 dt. So this will give you t by 2 minus sine 2m pi t divided by 4m pi from 0 to 1. So this will give you the value 1 by 2. Sine 2m pi will be some 0 since m is a natural number. Sine 0 is again 0. Okay, so this will give you. Did we done some mistake? Let me just re-verify it, please. Question number 3. Okay, so it's correct. So this is 1 by 2, and the other one is fx with sine m pi ln x, that is 1 to e 1 by x. And what is fx we have given? E to the power x sine m pi ln x dx. Again, if you will substitute, so you will get 0 to 1, 1 by x, and dx will be dt, and x is e to the power t sine m pi t. Now, obviously, we don't know how to integrate this, so we will keep it like this, and we will get our series, that is e to the power x can be represented as n0 and 1 to infinity cn. What is the value of cn? Value of cn, this will be the division of these two quantity, that is 2 times of 0 to 1 this integral e to the power t sine m pi t dt, this integral into the function, that is sine m pi ln x, where this x is varying from 1x to e. So this is your expression, that we have expressed this function in the series of eigenfunction of problem number 3. Okay, so a similar question with this is question number 6. Expand the function x square in terms of the eigen functions of the problem 4. So here we have to express this function in terms of the eigenfunctions of x square, eigenfunction of problem number 4. So in problem number 4, our eigenfunction is e to the power minus x sine nx, while our inner product is, here is the inner product, e to the power 2x, weight function is there. So we need to we need to take care of that function. So from here, fx is equal to summation n 0 to infinity cn e to the power minus x sine nx. So this is your eigenfunctions. And what will be the value of cn? Cn can be expressed as, from the above question, you can observe that fx comma e to the power minus x sine nx divided by e to the power minus x sine nx with inner product with e to the power minus x sine nx. Okay, so we need to calculate these two values. First of all, we will calculate the denominator sine nx comma e to the power minus x sine nx. We know that there is a weight function e to the power 2x, and when these two will multiply, so it will be e to the power minus 2x sine square nx dx. So this will give you 0 to pi 1 minus cos 2 nx divided by 2 dx. So what will be the value of this expression? So this will be some x by 2 minus sine 2nx divided by 4n 0 to pi. It will be 0 at 0 and pi up at pi is also 0. So this will give you pi by 2. Okay. Next is fx inner product with this eigenfunction sine nx. Since there is a weight function e to the power 2x and this is x square e to the power minus x sine nx dx. So this will give you 0 to pi e to the power x square sine nx dx. Again, this is a kind of expression that we cannot usually calculate. So what we will do, or you can even calculate while using that e to the power x sine nx expression. You know the integration of e to the power x sine nx, and then you can apply the integration by parts with the x square, and you may write the expression x square in the series form n 1 to infinity, the division of these two, that is 2 by pi, the integral 0 to pi e to the power x square sine nx dx. Here let us write in the form of some other dummy variable sine t e to the power t square dt, so that it will not disturb the expression, and the actual eigenfunction is this. So this is your representation of this x square in the form of eigenfunction, where this x can vary 0 to pi. So this is your expression for this series. Before moving to the next question, or you can say we will do it in the question. So question number 7. What we have to do here, find the first 4 terms in the Fourier Legendre series of the function. What is the function? Function is cos pi x by 2. Okay, we have given the function is pi x by 2. We have to find out its Fourier legend series. So what is the general expression of Fourier Legendre series? That fx can be written as n 0 to infinity some cn p n x dx. Okay, where this sorry, here it's a series. So where this cn is 2n plus 1 by 2 minus 1 to 1 fx into pnx, and pnx is here Legendre polynomial, which can be find out from 1 by Rodriguez formula 2d by dn x square minus 1 to the power n. So what you have to do, you have to find out p0, p1, p2, p3, and then you have to put these values in this expression. Then you have to find out this series expression. Try this one. So let us first find out this Legendre polynomial. So what is p naught x? This will be 1 by 2 0 to the power 0, zeroth derivative. Zeroth derivative means we don't need to derivate it, so it will be directly equal to 1. P1x will be 1 by 2 to the power 1 factorial, first derivative or one time derivative of this x square minus 1. So this will give us 2x divided by 2, that is x. The second Legendre of second degree is 2 to the power 2, 2 factorial, d square by dx square, x square minus 1 whole square. this expression. This will be 1 by 8 d by dx of 4x into x square minus 1. So if you will differentiate it again, so you will get 3x square minus 1. Next is p3x, which will be 1 by 2 cube of 3 factorial, third derivative of this x square minus 1 cube. So what will be its third derivative? So if you will solve it, 8 into 6, this will be some 48. So if you will do one time derivative, you will get here 3 x square minus 1 whole square, and x square derivative of x square will be 2x. So it will be 6x x square minus 1 whole square. Now if you will differentiate it again, this will be 1 by 8. Oh, sorry. Okay, I think there is some technical error happen here. So whatever I wrote, uh, it's got erased in some way. Okay, let it be. I'll do it again for you. So till then, let me continue this question. So our P naught x was, so we will continue from P3x. So P3x was 5. I'm directly writing 5x cube minus 3x divided by 2. So we need to use this P naught, P1, P2, P3 to find out the value of CIs. So C naught will be, it was 2n plus 1 by 2, so it will be 1 by 2 minus 1 to 1. And what was your function? Our function was cos pi x by 2. So cos pi x by 2 into 1 dx. If you observe here, this is an even function. So you have to integrate from 2 times of 0 to 1 cos pi x by 2 dx. So we are using the property minus a to a fx dx. This is nothing but 2 times of 0 to a fx dx if fx is an even function, and it is 0 if fx is an odd function. So this is your expression that we are uh, using. So next is C1, 2n plus 1 by 2, that is 3 by 2 minus 1 to 1 cos pi x by 2 into x dx. Again, now it's an odd function. So since it's an odd function, what will happen? This will be 0. Next is C2, 2n plus 1 by 2. Again, this will be 5 by 2 minus 1 to 1 cos pi x by 2 into 3x square minus 1 by 2 dx. If you will observe, this is an even function. So since this is an even function, this will be 5 by 8, or if you will 2 times of this, so this will give you 5 by 4, 0 to 1, this expression 3x square minus 1 cos pi x by 2 dx. Now you have to integrate this 5 by 4, 3x square minus 1 sine pi x by 2 pi by 2 minus 6x. What is the derivative of sine? It will be minus cos, so this will become positive sine pi x by 2 divided by pi by 2 whole square. And the Another expression will be with negative sign, 6 sine pi x by 2 pi by 2 whole cube 0 to 1. So from here we need to calculate this value. So 5 by 4, if you will substitute 1, so sine pi by 2 is again 0. So we don't need to write this one. Cos pi is will be contribute something. So this will be, sorry, cos pi by 2 0, sine pi by 2 is 1, my bad. So this will be 2, you can say. If you will substitute 1, so this will give you 2. And here denominator there is already pi by 2. So this will be 4 by pi plus 0 with negative sign. Here it will contribute 2 to the 4 to the 8. So 48 by pi cube with negative sign. When you will substitute 0, so this expression will be 0. This expression will be 0 and last expression will be 0. So you will get this quantity, this much quantity. So this is 5 by pi minus. So if you will solve it, so you will get here 12 and 12 5s are 60 by pi cube. So now you got your what is your coefficient, and you will write that your function, and that means cos pi x by 2 can be written as, since c naught is 2 by pi, 2 by pi p naught x plus 0 times p1x, and so we don't need to write that, 5 by pi minus 60 by pi cube. I think there is some, I think, calculation error happened. Let me check it. So it's about 3x square minus 1 by 2. So it's about 3x square, since the 3x square by 2. So we know that 2n plus 1 by 2. So this will be, just a second please. So this expression will be nothing but, uh, when you will substitute here, it is 5 by 2. So minus 1 to 1. So from here there is one more 2. Okay, so there is one less 2 here. So if you will, so let me write it. So there is 5 by 2. Till now it is correct. So this will become 5 by 4. But from here there will be a contribution of 2. So this will be 5 by 2. 5 by 2. Till now it's 5 by 2. Now we left with 3x square minus 1 cos pi x, and 3x square minus 1. This will be sine pi x by 2 divided pi by 2, and differentiation of this will be 6x with negative sign, and since we are again integrating sine as cos, so it will become positive cos pi x by 2 pi by 2 whole square, again negative sign, and cos will become again sine, sine pi x by 2 pi by 2 cube. Okay, when you will substitute 1, you will get here 2 times of um, 2 times of this sine 1, sine pi by 2 divided by pi by 2, that is 4 by pi. And next is 0, since cos pi by 2 is 0. And next is, this will be pi by 2 cube, that is 48 by pi cube. When you will substitute 0, sine 0 is 0, here it is a factor of x, and here it is again 0. So you have to multiply with this pi by 2. So this will give you 10 by pi, and when you will divide this with this, so 24, that means 120. Okay, there will be a factor of 2 more here, so 120 by pi cube. So from here, next is C3, since we want to calculate till the 4 terms. So C3 will be minus 1 to 1, 2n plus 1 by 2, that is 7 by 2, and our function is cos n pi x by 2, and our P3x is 5x cube minus 3x divided by 2 dx. So this is an odd function. Since this is an odd function, this integration will be 0. Now you can express this m cos n pi x by 2 as first factor was 2 by pi p naught x. Second factor was 0. And third factor was 10 by pi minus 120 by pi cube p2x plus dot dot dot. There will be only a contribution of this even terms. No odd terms will involve here. Okay. So let me write the last question, which is somewhat similar to this one. We have to find out the three terms. So question number 8, find first three terms in the Fourier legendary series of the function 0 in x minus 1 to x to 0 and 0 to x to 1. So we need to write this Fourier series. So what we will do? So again, we recall that p naught x, p1x, and p2x. So Cn was minus 1 to 1, 2n plus 1 by 2, fx into pnx. So C naught is 1 by 2 minus 1 to 1 fx into 1 dx. So this can be written as 1 by 2, since minus 1 to 0 for function is 0. This will be the integration of x dx. This will give you x square by 2, 0 to 1, and 1 by 2 is out there. So there is 1 by 4. Now C1 will be 3 by 2 minus 1 to 1 fx into x dx. P1x is x. So this will give you 3 by 2. Since minus 1 to 1 minus 1 to 0 function is 0, this will be x square by 2, and this will give you 3 by 2 x cube divided by 3 from 0 to 1. So this will give you 1 by 2 as a contribution. Then C2 will be 5 by 2 minus 1 to 1 fx 3x square minus 1 by 2 dx. Since minus 1 to 0 function is 0, so this will be 5 by 4, 0 to 1, and otherwise it is x, so this will be 3x cube minus x dx. So this will give you 5 by 4, 3x to the power 4 by 4 minus x square by 2, 0 to 1, 5 by 4, 3 by 4 minus this 2 by 4, which will give you 5 by 16. So you have calculated first three terms. Now you may write this fx in the form of, first one is 1 by 4, 1 by 4 p naught x. Second one is 1 by 2 p1 of x. Third one is 5 by 16 p2 of x, and so on. So this is your Fourier legendary series. So that's all for today's lecture. If you have a query, you can ask. Okay. So thank you for the joining. Thank you for joining. Let's meet in the next tutorial.